All right, let's dive right into today's explainer. We are going on a really fascinating journey to map out the future of technology. For the longest time, hitting human-level artificial general intelligence, what we call AGI, was basically just considered far-fetched sci-fi. But today, it's a very real target for the next decade. So the big question is, what actually happens after we cross that finish line? Well, based on some incredibly deep and honestly mind-bending recent research from Google DeepMind, we are going to explore this massive transition from human-level AI all the way to artificial superintelligence. To really wrap our heads around the sheer urgency of this, we've got to look at the numbers. Consider this crazy fact. The effective compute used for AI models is currently estimated to grow by a staggering 10 times every single year. We're talking an entire order of magnitude annually. And this isn't just about plugging in faster microchips. It's this massive compounding effect of better hardware manufacturing, billions of dollars pouring into infrastructure, and surprisingly, constant improvements in algorithmic efficiency. Because when the code gets smarter, it's literally as if you magically multiplied your hardware overnight. And that mind-boggling, compounding growth is exactly what sets the stage for our entire discussion today. We're using a highly theoretical, wonderfully detailed paper published by researchers at Google DeepMind as our ultimate roadmap. They essentially set out to systematically figure out how AI itself might keep evolving in a post-AGI world, charting out this entire continuum of machine intelligence. So here is our quick roadmap for the explainer. First, we'll look at AGI versus ASI, then explore the digital advantage, outline 4 specific pathways to superintelligence, check out the bottlenecks slowing AI down, and finally, look ahead at the unpredictable future. First up, AGI versus ASI, where we really need to define our destination. So, people toss around AGI and ASI like they're the exact same thing, but there is a totally stark contrast between them. In this DeepMind framework, artificial general intelligence basically represents median human-level capability across most cognitive tasks. Essentially, it's about as smart as your average everyday person. But artificial superintelligence, that is an entirely different beast. ASI is defined as a system that completely blows past the performance of a collective of 10,000 well-coordinated human experts working together for a whole decade using all the best tools we currently have. I mean, that is just a colossal leap in brainpower. But we've got to burst that sci-fi bubble for a second. An AISI is not some all-knowing, all-powerful magic entity. It is strictly tied down by fundamental physics. It can't break the speed of light. It's totally bound by the speed of real-time simulations. Like, if it wants to observe complex weather patterns or how biological organisms grow, it literally just has to wait, because those things take time in the real world. And maybe most importantly, it's limited by the physical universe. Actually building things like manufacturing chips or laying down power cables takes real-world time and energy. Moving right along to part 2, the digital advantage, and looking at exactly why AI can blow right past biology. When you actually stack up our biological brains against digital minds, it's honestly not even a fair fight. Think about it. We read and speak so slowly, right? But digital minds have wildly high bandwidth inputs and outputs. They can inhale whole libraries in a few seconds. We're stuck inside one fragile physical body, while AI is substrate independent, which is just a fancy way of saying it can copy itself across any compatible hardware anywhere. When a human expert passes away, an entire lifetime of knowledge goes with them, but digital models have perfect memory and can copy themselves without losing a single byte of data. And while we take generations to teach our culture, AI can instantly share a brand new skill across millions of systems. As you scale up compute, those digital advantages just multiply to infinity.
Okay, on to section 3. Let's look at the 4 specific pathways actually leading us to superintelligence.
Pathway number 1 is pure brute force scaling. If you think about intelligence as basically just a really complex search engine, like searching for the best prediction, the best plan, the right answer, then feeding a system way more compute, absolutely massive data sets, and bigger models gives you a wildly superior search. And we've seen this happen in the real world. Performance scales super predictably when we just feed these models more data. So the question isn't really if scaling works, but how long we can physically and financially afford to keep that exponential growth going. Then we have pathway 2, which is all about paradigm shifts. This recognizes that just making today's models bigger and bigger might eventually hit a brick wall. To actually reach ASI, we are going to need some radical algorithmic evolutions. We're talking about moving from models that just spit out text to systems that do dynamic test-time computation.
It means breaking through current memory limits so an AI can learn continuously its whole life without suddenly forgetting old stuff, and shifting toward these robust internal world models, where the AI can literally simulate complex futures in its head before making a choice.
Pathway 3 is recursive improvement, and honestly, this is where things get wild. This kicks in when AI systems start directly speeding up AI research. Picture an AI that is automating its own hardware design, writing better code for itself, and generating its own perfect synthetic training data. When an AI can upgrade the exact tools used to build the next, smarter generation of AI, you get this massive self-amplifying loop that could spark an explosive, super exponential growth curve, rocketing us from AGI to ASI way faster than anyone expects.
Finally, Pathway 4 is multi-agent coordination. In this setup, AI isn't just one giant godlike brain in a server room. Instead, it emerges from millions or even billions of specialized AI agents, all talking to each other. Think of it like a fully automated digital corporation or a hyperspeed virtual economy where AI workers are trading data and solving problems together in milliseconds. Just like human progress comes from our organized societies and markets, artificial superintelligence could just be the result of a perfectly coordinated digital workforce. Now, you might be wondering, if we just throw an endless supply of microchips at these 4 pathways, is that a guaranteed ticket to artificial superintelligence? In theory, maybe. But in reality, just brute forcing it hits massive physical and financial walls really fast. To keep moving forward, we absolutely have to have those algorithmic leaps and paradigm shifts we just talked about. Basically, more compute is totally necessary. But without constant qualitative innovation in the software, it's just not going to be enough on its own. That brings us perfectly to Section 4, the actual bottlenecks of AI progress. According to the research, there are a few massive roadblocks we're going to hit. First is the infamous data wall. We are literally running out of original human text on the internet to train these giants on. But to counter that, researchers are generating high-quality synthetic data, using AI self-play and running endless simulated environments. Next up, we have real-world resource limits. We're talking energy grids tapping out and chip shortages. The fix for that? Huge infrastructure buildouts combined with AI figuring out way more efficient ways to run the servers. And finally, as any science gets more advanced, the research just gets inherently harder. But again, if AI can take over the heavy lifting of the research process itself, it might totally cancel out that slowdown. But the really fascinating hurdle is this concept researchers call the abstraction barrier. Today's AIs are amazing at remixing stuff humans have already figured out. But can they actually discover completely new science on their own? Think about it like this. If you only ever trained an AI on ancient pre-industrial texts, could it somehow invent the concept of quantum mechanics out of thin air? Probably not. Without physically interacting with the real world, running lab experiments, testing hypotheses, and seeing actual physical anomalies, an AI might hit a hard limit. That barrier could basically cap its intelligence, meaning it would still have to wait for human scientists to do the slow physical lab work. And of course, all this tech stuff spills right over into the real world, causing a huge socio-political tug-of-war. We are looking at a massive tension here. On one side, as AI gets crazy powerful, you might see massive societal backlash. We're talking deliberate regulatory slowdowns, strict licensing, and safety caps, which makes total sense from a safety perspective. But pulling in the exact opposite direction is the unrelenting force of global military and economic competition. Nobody wants to be the country that regulated themselves into losing a global tech race. This incredible friction between cautious safety and full-throttle competition is absolutely going to dictate how fast we hit AGI. Which finally leads us to Section 5, staring right into an unpredictable future. Alan Turing actually hit the nail on the head years ago when he said, "We can only see a short distance ahead, but there's plenty to be done." The road to ASI is incredibly blurry. We don't know exactly when it will happen or which of those 4 pathways will cross the finish line first. But what is completely clear is that intelligence doesn't just mysteriously stop evolving once it hits the human level. This transition leaves us with a colossal challenge today. If we are actively building systems that think at digital speeds and can coordinate as a massive super collective, what kind of society do we need to start designing right now to ensure we actually thrive in a post-AGI world?